In this video, we're going to be looking at how to identify series and parallel elements. In the circuit that we're working through, which you'll find in the first video, we're going to see that some of the elements are drawn in series and parallel in such a way that it's very clear which one it is. In more complicated circuits, it might not be quite so clear. If that's the case, then we'll have to use the techniques we develop here, but be a little more clever in using them. For our purposes today, though, I'd like to show you what it would look like when everything is drawn in such a way that we can just take our pens and draw through and see. The first step is to talk about what does series really mean. So recall, two elements are in series if they share current. What this means is two things. Number one, they lie on the same branch. Number two, the node between them has no other connections. So what does that look like? Here are two resistors. They're in series. First of all, they lie on the same branch. Second, here is the node between them, and there's no additional nodes coming off of it. In contrast, here are two resistors, but if I put another branch going that way, they are no longer in series. The reason is because although we might be able to draw a straight line this way, we also have to account for the branch going down. If you think of this from the perspective of the current, if I have a current I coming in, then I'm going to have two currents, I1 and I2, coming out. Therefore, this resistor and this one do not share a current. What about parallel? Resistors in series shared current. In parallel, we share voltage. When we're dealing with resistors in series, how we can do it to determine whether or not two resistors are in series is to put our pen onto one of them and draw a line along the circuit to the other. If we don't cross any other branches, then they're in series. For parallel, though, it's a little more challenging. And that's because we can draw a circuit in many ways where it will look very different, whether it's in parallel or not. I'm going to show you two examples. One is what we might call the canonical example, the one that's clear to see because the resistors themselves are actually drawn parallel. The other example, which you may notice from class, tutorials, or your textbook, has resistors that are in parallel, but it doesn't quite look so obvious. Here's the canonical example. Here are my resistors, and they are certainly in parallel. But how do I really know that? I can say that they share two nodes. To determine that, let's highlight the nodes and see what we end up with. The first node is here. And you'll notice at the very beginning, both of my resistors share that node at the top. The second node is here. And you'll once again notice that both of my resistors share the node at the bottom. Since resistors only have two nodes to connect to, if we share a top node and a bottom node, then they must be in parallel because the voltage at the top and at the bottom is the same. Here's a slightly more complex example. In this example, it really matters where I draw my terminals. I'm going to claim that these two resistors are in fact in parallel. How do I know that? Let's once again highlight the nodes. I'll try to do this in a different color. The first node is here. The second node, let's change colors again, is here. If you take a look at these resistors, you'll see that from the perspective of these 2 points here, at the top of this resistor I have a red node, which is connected to this resistor, also red. At the bottom of this resistor I have the green node, which is connected to the other end of this resistor, also green. So once again, these are in parallel, I beg your pardon. And why? Because they share 2 nodes. Anytime we have this phenomenon going on, we can guarantee that our resistors are in parallel. Notice that in reality, you can have parallel, series, or something else entirely. I'll draw a circuit, in fact it'll be the circuit we've been working with, and you'll be able to see that although some of the resistors are in series and some are in parallel, some of them are neither. We had our source and the resistor, a voltage source, and 2 further resistors. For the purposes of today's discussion, it doesn't matter what they were. Now, the question becomes, what is in series and what is in parallel? Let's change to blue, and let's see if we can figure out which of these resistors are in series. One technique I like to use is to start somewhere on the resistor that I'm looking at and drawing a line to the others. If I end up finding another resistor before I end up at a node that goes and branches off, then those 2 resistors are in series. From this one, following along, I've encountered a different branch. So this resistor is not in series with any of the other resistors. If I go the other way though, I see that it is in series with the current source. I'll leave it to you to see if you can find, for every other resistor, that they are not in fact in series, with the exception of these 2 on the right. If I begin here and I draw a line, I end up at the other resistor. I haven't hit any other branches, so these 2 are in series. If I go the other way, I end up at a branch. Therefore, these 2 resistors are only in series with each other and nothing else in the circuit. What about parallel? I'm going to color some of the nodes. I'll color that node red. I'll color the bottom node green. Automatically I can see that there are 2 resistors that do in fact share both nodes. These 2 resistors here share the red and the green node. Therefore they are in parallel. If you take a look, and let's color the rest of the nodes, there is nothing in the circuit that shares the yellow and the green. There is nothing in the circuit that shows the light blue and the green. And our final node there is nothing in the circuit that shares the purple and the green. As a result, the only two resistors that are in parallel are the ones that share the red and the green that I have noted here. Now that we know what is in series and what is in parallel, we can use that to reduce the number of unknowns in the circuit. I'll come back to that in the next video.